Hello friends, in this video we are going to learn basic elements for HMI screen designing, which are button, switch, symbolic IO field, graphic IO field, date time field, IO field and bar. Finally, we will see a practical project on HMI screen design. Alright. We have seen how a PLC or HMI can be inserted into the TIA. Here we have a PLC and an HMI. First, let's connect them together. The PLC hardware has only a CPU. Let's write a simple program for that. Suppose this PLC can turn a motor on. We want to use this bit of memory to stop the motor from the HMI end. Let's save this program and transfer that to the virtual PLC. Now we are going to design our HMI screen. Well, from the Elements tab, insert a button. Let's change its string to a start, a stop. Now select the button to see its properties at the bottom. Like objects, here we can change some properties of the selected button. The more important part is the Event tab. Here we can determine what the inserted button can do. For example, when to press the button or to click on it. On the right side, we can search and use permissible functions to use. Search invert bit. Now let's select the start-stop tag from the PLC tags table. So when we click on this button, the M0.0 address of my PLC memory, which its tag is a start-stop to switch between 0 and 1. Now let's insert a simple circle. As you can see, it does not have any functions on the Events tab. Let's use this circle to show the state of the motor, like in the previous videos. Now let's save this screen and simulate that. As you can see, we can turn on off the motor with this button. Alright, let's see how we can have a momentary button like real push buttons on the HMI screen. First, let me modify the PLC program. We have seen this program before. Let's transfer that to the virtual PLC. Alright, on the HMI screen we need a start button. Let's modify the inserted button and change its string. Also, let's change its color. Now let's go to the Events tab. Let's delete the previous function first. When this button is pressed, we want to set the start tag in the PLC program. So search this function setBit while key pressed. Now select the start tag from the PLC tags table. Here we can change the bit number. Now the inserted address has only one bit with this bit number. Also, we need a stop button. So let's create a copy of the start button. Now let's link this button to the stop tag of the PLC program. See here, when I select the start tag from the PLC tags table, here the start stop tag appears. Why? Pay attention, in the HMI screen design, the PLC addresses are used to link to the HMI. Tags just help us to understand the logic of PLC programs or HMI screens. Here we have two tag tables, PLC and HMI tags table. In the previous project, when the M0.0 address has been inserted into the HMI screen for the first time, the start-stop tag has been created for the M0.0 address on the HMI tags table automatically. Now when I am inserting the M0.0 address for the second time with another tag name, HMI uses its previous tag for the M0.0 address. So, let's delete the previous tag. Now let me insert the start tag again. Alright, let's change the stop button color. Now let's test this HMI screen. As you can see, the start and stop buttons on the HMI screen work like real start and stop push buttons. Now let's have an emergency switch on the HMI. Remember, we used a switch in the previous video. Now let me change its mode to switch with text. Here we can link the inserted switch to an address of the PLC. So let's get back to the program and use a normally closed contact for the emergency state. Note that an emergency is not a push button. It is a maintained button. Alright, let's transfer the modified program to the virtual PLC. Now let's link the selected switch to the emergency tag in the PLC program. Here, this text will be shown when the switch is on. So let's change it to emergency is pressed. Here we can write a suitable text which will be shown when the switch is off. Alright, we need to change the switch appearance. Since its text is not visible, go to the appearance. Alright, let's download the logic again and test it. As you can see, the emergency switch holds its last state until it is pressed again. Alright, let's see another element that can be used on the HMI screen. Insert a symbolic I/O field. At the Properties window, select the General section. As you can see, this element needs a text list. Here we can create and manage text and graphic list. First, we should write a name for the new text list. We want to create a text list that we will use it to show if the motor is on or off. Now let's get back to the HMI screen. Link the inserted element to the motor tag in the PLC tags table. This tag has two states, on or off. Now let's insert the created text list that has two texts corresponding to each motor state. Now insert a graphic I/O field. Similarly, we need a graphic list here. So let's create a graphic list. Click on graphic list. Here we are going to create a graphic list that will show the motor states. At this window, we can select the default or the last used graphics. Also on the right side, there are many suitable graphics. Let me find and use two motor graphics, which are green and red. Now, like the symbolic I/O field, link this element to the motor tag. Also here, select the created graphic list. Well, let's sort inserted elements on the HMI screen. Let me remove the background and border of this graphic. Okay, let's simulate the screen. Let's turn on the motor. Well, I must release the emergency button. As you can see, when the motor is on, these three elements show the state of the motor. Also, we can change the motor state with this element. Now, we are going to learn other elements which can be used on an HMI screen. This is the HMI screen that was designed before. Now to start the motor, I should release the emergency button. As you can see, when the motor is on, these three elements show its state. Also, we can change the motor state with this symbolic I/O field. Here is a simple point in using symbolic or graphic I/O field. For example, select this symbolic I/O field. Here we can change its mode. Now it works as input-output. So this element can read and change the connected tag state. Let me change its mode to the output mode. So this element will work as an output. It cannot change its status. Let's test the screen again. As you can see, at this time, we cannot change the motor state with this element. Okay, let's take a look at another element. Here is the date and time field. At its properties window, we can select which item we need to show. Time, date, or both of them. This element can get its time from our system or a PLC memory. Let me select the system time. Another element is the I/O field. With this element, we can insert and see numbers. First, let's use an on-delay timer in the PLC program. As you know, this timer needs a data block. Finally, I enter 4 seconds as its preset time. Now let's move this program to the virtual PLC. Now I am going to design an HMI screen to see and modify the preset time and the elapsed time. Let's insert an I/O field. Let's insert an I/O field and then at its properties window, find the inserted timer data block and link the I/O field to the preset time parameter. Also, we can determine its number format. Let's insert a text here. Now let's have another text and I/O field to show the elapsed time. Well, let me connect this I/O field to the elapsed time of the inserted timer. Here I changed its mode to output because we don't need to change the elapsed time. Let's simulate the screen. As you can see, I must hold the start button for 4 seconds to start the motor. Alright, let's change the preset time to 5 seconds. Let's start the motor. Again, the motor is on after 4 seconds. It seems there is a problem. Alright, when the timer starts its work, it gets the preset time from this constant number, not from the HMI. To resolve this problem, let's use a memory here which the HMI screen can change its value. We cannot use MD0 because the byte 0 is used here. Let's use MD1. Okay, let's transfer this program to the virtual PLC. Also, let's connect the first I/O field to the MD1 memory. Let's simulate the screen again. At this time, the preset time value is 0. Let's change it to 5 seconds. As you see, now I can change the preset time to any number. Also, you can see my system time on the HMI screen. Alright, let's see the next element, the bar, which can be used on the HMI screens. Let's insert a bar and an I/O field. We want to change an analog output directly from the HMI. So let's modify the PLC program. Let me insert a move instruction. Here let's use the memory that the HMI can change its value with the last inserted I/O field. On the right side, we have an analog output address that we want to see its value with the inserted bar. Let's transfer this program to the virtual PLC. Now let's link the inserted elements to the PLC addresses. Here we can change the bar scale, assuming the entered numbers are between 0 to 1000. Okay, let's simulate this HMI screen. Let's change the display format to decimal. As you can see, we can change the analog output directly from the HMI screen, and also this bar shows its value. If the entered number is out of the bar range, an error does appear. Similarly, I can test the program with my PLC and HMI. As you see, I can use the HMI to turn on the PLC output. Also, I can change the preset time of the on-delay timer. Let's change the preset time to 5 seconds and turn off the output. Now I must press and hold the start button for 5 seconds to turn on the output. Like the previous simulation, I can send a number to my PLC or read memory values and show them on the HMI. Alright, we have seen what the basic objects and the elements are. Up until now, we have designed some HMI screens with basic elements and objects. Now let's see a practical project on HMI screen design. Let's have an overview. This is the industrial automation pyramid. As you know, we can use Factory IO to simulate our industrial process. In this video, we are going to control the liquid level of this tank, which has 2 electrical valves and 1 level sensor. Also, we will use a virtual PLC to simulate or program and use an HMI to monitor a process. We can simulate a designed HMI program as well. As you know, the TIA portal is the basic software to program PLCs to design HMI screens, set their connection settings, and to extend the projects. That is wonderful, and we can perform all of these functions on our computers without using any hardware. First, let's test the project. Here we have this tank which is linked to this virtual PLC, and this is the designed HMI with 3 screens. We can see the time, date, and PLC goods logo on the main screen. Here we can add other information. Let's go to the tank 1 screen. In this screen, the liquid level of the first tank can be controlled. This tank has 2 control types, manual and automatic. Let's test the manual mode. With the fill button, we can turn on the filling valve. Also, until the discharge button is pressed, the discharging valve will be open. Always the liquid level is shown in %. Let's go to the automatic mode. When this mode is selected, the screen will be changed a little. Here we can enter the desired level. Let's write 80%. So the filling valve will be opened until the liquid level to reach the desired amount. As you can see, when the level reaches 80%, the filling valve is turned off automatically. Here, if I click on the discharge button, it makes the PLC to turn the discharging valve on until I click on that again. As you can see, when the liquid level goes under 80%, the filling valve will be opened automatically. Now I am going to explain the project. After that, I will extend this project to a system with 2 tanks. Alright, we have this tank with these analog valves and level sensors which are linked to my virtual PLC with these input-output addresses. In the TIA, we have a PLC and HMI which are connected together. Let's review the tags which are defined in the PLC program. Here we have a bit of memory which determines the auto manual mode. Then 2 bits of memory are used to turn on the valves. These bits are activated by the buttons on the HMI screens. The next tag is level sensor to get the related signal. The digital display tag is used to store the level liquid in percent. Finally, the two analog outputs are used respectively for the filling and discharging valves. As you know, here we can see general information about the PLC program. We can also see input, output, and memory addresses which are defined in the program. Here we can check to see if there is any cross-reference between addresses. Alright, let's see the PLC program. Here are the functions that are called from the main block. In the first network, this function is used to link the virtual PLC to Factory IO. In the next network, this function gets the level sensor signal from the PLC input, then converts and stores it in percent at this PLC memory. For this conversion, the norm and the scale instructions are used. Well, the main part of the program is the third network. Here there is a function for manual and function block for the automatic modes. The program inside the manual function is simple. When the fill button is pressed on the HMI screen, this number will be moved to the PLC output to generate 10 volts to open the filling valve. Similarly, the discharging valve can be opened. Alright, this function block has been used for automatic mode because its program needs a data block to store and use the desired liquid level value. In the first network, the used logic for the discharge valve logic has been told in the manual function. The next network is related to the filling valve. When the level of a liquid is greater than the desired value, the filling valve will be closed. Otherwise, it will be open. The main point is the desired level parameter, which has been defined here. Its initial value is 50%. The parameter will be stored on the related data block and can be changed by the HMI. This logic can be used for the second tank, but we must use another data block to store the desired level for each tank. Now let me explain the HMI part. As you can see, this screen has a green arrow, so the HMI starts its work with this screen. If we click here, another screen will be added. Now here are three screens. We need to navigate between them. To do that, we can insert the buttons and use the Activate Screen function in the Event tab. Let me show you. Here under the screen menu, select Activate Screen. Now we can select the desired screen. Now let's go to the tank 1 screen. This switch determines the control mode, which is connected to the manual auto tag of my PLC program. Here there is a simple bar that is connected to the digital display tag. Behind the bar, the tank graphic has been inserted from the write list. Also, this simple blue rectangle will be shown if the filling valve is open. Pay attention, the filling valve is analog, and based on the PLC program it will be open if the related address is between 1 to 27648. Alright, as you see, when a valve is open, its graphic color will be blue. We can have this ability with graphic list, which has been explained before. For example, for the discharging valve, this is the connected PLC tag and this is its graphic list. Here we can create and manage our graphic list. If you want to use this graphic list for a button, you need to change its properties. Now let me show you another technique. First, create a copy from the fill button, then place that on the fill valve, and then select the invisible at its properties. Now let's test the screen. As you can see, if I click on the filling valve graphic, the valve will be open. Alright, here are some elements which are placed together. When we switch between manual and automatic mode, appropriated elements will be visible. I explained how to change the elements visibility already in the previous videos. Here we have used the manual auto tag to determine each element's visibility. Now let's extend the project. First, let me insert a second tank. Then its valves and the level sensor must be linked to the virtual PLC. To modify the PLC program, we can use the previous functions for the second new tank, but their input-output must be modified. Here I must change the input function. The second level sensor is linked to the IW34, and also I must use another memory to store the liquid level of the second tank. I can enter the new addresses or use new tags which I have defined before. Here, pay attention to the function and function block difference. We can use the previous function block logic for the second tank, but we must change its data block because each tank has its specified desired level. In the same way, we can use the previous tank screen for the new screen, but we must modify their tags. For example, we must modify this bar tag to the new PLC memory address, which is used to store the liquid level of the second tank. Alright, after modifying new tags for the second tank, now I have two tanks and each tank can be controlled by the HMI. I recommend you to practice doing these simulations if you have a real PLC or an HMI devices available to understand and learn the subject better. Alright, in the next video we are going to see other HMI abilities like defining passwords and alarm screens. Thank you for watching this video. I see you in the next one.